Alrighty. Where to kick this off from? Boy, I don't know. All right. So it is Thursday. Thursday night. I have tonight and tomorrow before I have to have these wings loaded up and ready to go over to Indianapolis. And the universe, as always, has decided to go totally pear-shaped on me. Along the way, when we last left off, I was just gotten out the new heavy-duty linear actuator that I was going to try and use to control the flap mechanism on these wings. Now, as I was trying to fit this up here, I found I couldn't find any way to mount this to get decent action out of it, and so this just was not happening. And over the course of the same evening, the one operational 3D printer that I had decided it was going to give up the ghost, and I think I need to replace the thermal sensor on the print head to get that going. So at that point, I had 0 operational 3D printers. So I'm like, okay, what am I going to do? I've got one 3D printer that I knew just needed a cleaning and some basic maintenance. So I figured an hour's worth of work, I could have it back up and running. At the same time, I was trying to decide about this, and in the midst of my preparation for Harry Carey, it came to me. I have uncompleted projects around my basement. Among them, the start of a robotic dog. This robotic dog has quite a few servos. These servos are rated for 20 kilograms. A little bit of math, and you realize that 20 kilograms is about 44 pounds. Certainly more than capable of moving these wings. Servos, instead of a linear in-out motion, is a side-to-side motion, almost like a flapper. So I did a quick shift in things while I was trying to decide on which way to go with a few things and get a few last-minute parts together. I did some updated models. The wing guides, I've now added a little shelf on it with some screw holes on it, to which, here, let me put them in this way. Here is a mock-up of our wing assembly, and you see that this now sits here like this, and then I'm going to take a piece of flat aluminum and cut it down and make a linkage between the two pieces, so that as this turns, it will turn the wing. And we can turn it in, give it about a 90 degree in and out, almost. Kicker is these are digital. I can't just plug them into a battery and have them work. So while the linear actuators for the up and down are just power management, switches, and cabling, I need a digital system for the servos. Fortunately, I have a couple of Unos sitting around. For those not familiar, these are produced by Arduino. Pretty standard in just about everything. So, was able to sit down, do a little bit of work on them. In my haste and in my excitement, I was not paying attention, and I ended up accidentally plugging an 18-volt battery into a 12-volt board that was driving 6-volt servos. So I have managed to fry 2 servos, got an Arduino to release the blue smoke, and I was really just not happy at that point. Got lucky, realized I have one last Uno that was going to be part of another project. So it is going to be our new host for everything. Now this one ended up being a bonus. I had ordered it from a company that when they ship it, comes with a mounting case, a mounting plate for it, which saves me a little bit of design time, a little bit of work time on things, so we can hopefully get the ball up and rolling. I have spent a good part of an afternoon furiously writing some code to try to manage these. I've had some mixed results. I've got it working, sort of. Part of my problems, though, was that I did not have a reliable power source, and I don't have the switches in stock. Now, the switches, I can pick up at my local micro center. I'm lucky enough to have one in town. I don't have to order anything in. In the meantime, I also decided that, yeah, these battery packs are probably my best bet for power supply at this point. I went looking, hit a local battery shop, and everything I was looking at was either too expensive, didn't have enough juice, or was way too heavy, or some combination thereof. That was when I realized that, oh, these things actually do work. I just got to run the power through a couple of buck converters. One to give me 12 volts for the Arduino system, and for these servos, these will run on 12 volts. And then I need another buck converter to pull these down to anywhere between 4 and 6 volts. So I'm thinking a 5-volt buck converter, which will give me power for the servos. In the meantime, I went out online, did some poking around the various STL repositories, 3D printed items, and I found this piece, which I will provide a link it down and below for everything. But it includes not only a mounting place for contactors, but it also has the locking mechanism in place for this. Now, I can use this as as part of an assembly, make it a part of something bigger, whether it mounts on the pack or mounts on a belt clip or something I haven't quite figured out yet. We'll see how that goes. But this gives me a way to get power out of this battery and into a wiring harness. From the wiring harness, I can distribute to the appropriate power converters to then run off to this and this and this and everything. In the meantime, you'll notice that this wing is no longer sagging. I went out and I replaced the wood dowel with an aluminum dowel, 1/4 inch, same diameter. Then measured it, cut it to length, matched it up, just swapped them out. And I did a quick test. They thought of using the RAM board itself as the feather coverings. It's got the durability to maintain its shape, unlike fabric that will want to flap around. This is holding its shape beautifully. Spoke with the customer who is I'm doing this for, and they said that they liked the idea. They were wondering if, instead of having it like this, though, if we could do like 2 pieces, one on each side to kind of encase the whole thing. I think we can do that. So I went and grabbed some paint and primer and did a quick test because I wanted to see what kind of durability this would have with regards to weather. Never know what weather's going to be like. If you have to go outside and it's raining, you don't want your cardboard-based parts to get soaked and sopping wet and heavy and falling apart. So a couple of coats of this paint on here, and I took some water, poured it on here, let it spend a good minute sitting, and it did not soak in at all. So I think that's a solution for that. Because of my setbacks and because of everything else, the extra work for getting it to go the way we need to go, there's been a change in plans for this weekend. I'm still going over to Indianapolis. I'm still taking the wings with me, but I'm going to bring the roll of RAM board with me. And once we take 10-15 minutes to do final test fit for the harness, make sure the weight is good and everything. Wait, let me come back to that in a second. Once we do that, that'll take 15-20 minutes. We're going to take the RAM board we're going to have 3 sets of hands instead of just me, myself, and I. It's going to be 3 real sets of hands. And the 3 of us can work together to knock out all these pieces parts, which I can then bring back here, do the final assembly on the wings, get the feathers painted here because I have space to do it, regardless of weather. That's something that my friends over in Indy don't have. So that'll let me get the final assembly and everything done here. And I've got about 5 weeks, 5-6 weeks from this weekend until the convention. So that gives me time to do all the assembly, get everything done together, get the electronics done and sorted. And at that point, I think I should have enough extra time that I can do some decent weather-resistant covers to go over some of this. Now, where this leaves me for tonight, is I have these new pieces that I need to swap out. I have the last piece. There are 3 pieces getting done here. I've got this piece, and then you can't see it down here, but the base where this all mounts are all going to be reprinted. It's black, but it's a different black. These are printed out of Inland Tough PLA. The new pieces are printed out of Polymaker ASA. This is an engineering grade material, and these are 100% infill, so this is solid. It will not break. It should handle the weight very nicely. As you can see, all the pieces are spec'd just right. This new inset piece, if I can, I think I'm going to get rid of the PLA here as well, and I'm going to reprint this in nylon. That will give it some slightly smoother action. It'll be able to, it's a little more like it's lubricated, and that'll get us rolling on things. But first, I think what I need to do is I need to clean up this mess. I need to clean up that mess over at the drill press. Get the floor cleaned up so I'm not tracking aluminum shavings all over the house. That will keep Mrs. Dragon happy. Just start to try getting things organized for tomorrow. So I think at this point it's going to be kick it into, and I'm probably going to just take the whole thing, kick it into, words are failing me this week, I'm sorry. At this point, I think it's just put it over into time lapse, and we will see about getting ourselves organized and then being able to start mounting some of these new pieces and getting things collected together and ready to go. So let's switch it over.
Mid-project cleanup is just one of those annoying things that you have to get done, especially when you're working on a large project that has multiple components to it.
Alrighty, myself a little bit of working space cleared off here. I am kind of cleaned up now. I'm kind of retooled the workbench for doing electronics. I've got some 3D printed parts. I've got these new pieces here ready to go. The new base is currently printing. It's about a even running at 50 millimeters per second speed on the printer. This is going to be a 12-hour print job, so it'll be ready in sometime tomorrow morning. So I can't swap these out until that's in place. In the meantime, though, I can take one of these. I can fit this in here. And I can take one of these. And I can fit that in here. And just because I have them out and handy, I ordered a restock on some, there we go, on some hardware that I didn't have any. So I'm going to do this real quick. There we go. That makes it just a little bit easier, huh? What am I doing? I should have you over here looking at this, shouldn't I? All right. So what I got here, I haven't really given you a decent up-close look at these pieces yet. These came out pretty nice. Not 100%. Got some cracks there. before I mount these up permanently, I may fill these with a little bit of CA glue just to have them done and reinforced. In the meantime, though, that will slide right in there like that. And I'll throw in a couple of screws just to hold everything in place. I forgot. I made it to be a pass-through screw. I need something a lot longer. So let's go for, that's 45. So I need a 50. Uh-oh, do I have any 50s? $45s, $47s. These will do, and while I'm out at the hardware store tomorrow, I will see about grabbing some 50s. Please, oh please reach. You don't reach. Holy Toledo. Alright, you know what? You can just sit right there and just hold that like that, huh? Alright, so from here, out of the way, move the Arduino out of the way for just a moment here, and this piece will then fit in here like so. Aha! Alright, now I need, what do I need here? Let's make a piece that is, say, 10 will work. And this is going to be how wide? Ay. Let's say 42 between the holes. So we'll start by making a piece about 50. Okay, I know I've got some bar stock around here that I haven't used. Now, I'm going to do this very quick and dirty like.
I mark over the ends of the linkages so that I can mark for the centers of the screw holes. Puncture the holes off camera, then use a steel screw to tap the aluminum. Then I attach the linkage to the server and the wing rail. This is roughly how it'll look on the backpack. This assembly is just a rough draft. I need to reprint these inserts in nylon and see if the linkage allows enough rotation to support the flapping action. As always, thank you for taking the time to watch. I'll see you in the next video. In the meantime, go make something cool.